All right, so this is the second part of 5.4, and we are going to work on equations that look like this.
You're not showing your screen.
Well, that's unfortunate. Thank you. All right, what's the part of this equation that you're like, I really don't like that?
The exponent.
Yeah, that might be something that you're like, I don't like that exponent being like that. How do we get rid of, and let's talk for a second, we're not talking about this one in particular. How, if I wanted to, if I had like 3/2 x equals like say 10, how could I get rid of this?
Multiply it by 2/3.
And so we call that multiplying by its reciprocal, right? Because these guys cancel out. So when you have a fraction, if you multiply by its reciprocal, they cancel out to a 1 and they're no longer there, correct?
Mm-hmm.
Okay. Well, how do I get, because I want to get rid of this fractioned, but the problem is it's in a power spot. It's not like where the 3/2 was, which was in front of the x. It's in an exponential spot. So how do I get to multiply fractions when I'm dealing, like how can I make two exponents multiply each other?
You raise both sides to 2/5 power.
Yeah, because when you have, the rule was when you have exponent and you raise an exponent to a power, you multiply these two powers, right? So this would turn into x to the 6, right? Because you multiply the powers. So we want to get rid of this 5/2. So what our rule is we can do anything we want to an equation as long as we do it to both sides. So we can say, hey, you know what? I'm going to raise all of this to the 2/5 power, because when I raise power to a power, these guys multiply and cancel out. And then all I have to simply do is raise this to the 2/5 power. And so I end up with 2x plus 5x plus 5 equals, and then we have to think about this. This is actually 5(1). This reviews 5(1). This becomes my my index, 5th root of 1. There's my 1 to the 2nd power. Well, 1 to the 2nd power is 1, and then the 5th root of 1 is just 1. So it turned into a nice pretty 1 still. But if this was any other number, it would change. So I realize I have two types of x's. All right, so I combine this. I get x squared plus 5x plus 4 equals 0. This says same signs. This says they're both positive. X plus 4, x plus 1. What makes this 0? By minus 4. What makes this 0? Minus 1. And then what's the thing we must do to finish all of this?
Check our work.
And so we're going to plug it back into the OG, all the way back at the beginning. Can't plug it in anywhere else. When you plug in, use parentheses. So this turns into this, which we've talked about all year long. This is read as -4 squared, which equals 16. This is read as the opposite of 4 squared, which equals -16. These two things are not the same. This is the one you're looking for. That's why we say plug in using parentheses. Plus 5 times -4 plus 5 to the 5/2 power. And we're questioning, does that equal 1? That turns into a 16. That turns into a -20 plus 5 all to the 5/2 power. Does it equal 1? This turns to a -4. -4 plus 5 is 1. 1 to the 5/2 power. What the heck does that mean? That means the square root. That's my index of 1 to the 5th. 1 to the 5th is 1. Square root of 1 is 1. 1 equals 1. Check. So what I did is I checked for -4. I want you to now check for -1 on your own. By the way, it should work. So both of those are answers. You can do that towards the end when I finish up. If you can't get that to check out, you need to ask me a question at the end of class. So you still need to check this one. That will be your work at the end of class. Next type of problem. All right. Now we can only do this when we have this kind of by itself. If there's like a +7 or a 2 here, we'd have to get rid of this. We'd have to get rid of this. Then we can attack that guy. But since there's none of that garbage out here, I can attack this. I don't like that there. So I'm going to raise it to the, anyone know?
2/3 power.
And when I raise it to the 2/3, these guys cancel. But I'm going to raise this to the 2/3 power as well. And really, this is 3/1 times 2/3 because power to power we multiply. These cancel. This leaves me with 2/1 or just a 2. So I end up with x plus 18 equals x minus 2 squared. You cannot just distribute that. No, you cannot. Whoops. You cannot distribute that. That is wrong. So what does it mean to have x minus 2 squared? It means you have x minus 2 times x minus 2, and you must distribute it. There's also a pattern where I've been talking about throughout the year that says you can just square this, which is x squared, multiply those together, -2x, and then double it, -4x, and then square this number plus 4. If you distribute this out, you'll get that same exact answer. Now we're going to set it equal to 0. Zero equals x squared minus 5x minus 14. 0 equals different signs. Bigger one's negative. Two numbers that multiply to 14 but subtract to 5, 7 and 2. And again, x equals, well, x equals 7, x equals -2. What makes this bubble 0? What makes this bubble 0? And then if you go back and you check your answers, this one works, this one does not, which you must check your answers. So this would be your only answer for this question. When you plug this one in down later on, you get that 64 equals -64, which is not true. When you plug this one in, you get 125 should equal 125. So your job for the rest of the class is to check these two, plug in, make sure you get that this one works and that this one doesn't work. And I'm also going to put a last question up here for you to try, and we will go over this before we leave.